My name's Liam, if you don't know me. I look like that when I take weird photos on the airport, on the airplanes. One of the MVP guys. I work in the States, out of Winchester, Virginia. I am from here, but I do live in the States. I work for Protivity, and if you want to email me, my blog site is hello@liam.com, and my email address is there. I may not respond to you straight away. As I told my wife the other night, there is a 5-hour time difference. Yeah, my kids don't understand that either. So, what are we going to talk about? We're going to talk about the teams. We'll talk about red team, blue team. We'll talk about attacks. We'll talk about attack vectors. And we'll talk about the attacker from within and from the outside. And then we'll talk about protecting the infrastructure. Now, I'll just let you know, I do like to walk around. So if you feel sick, I apologize. In one of the sessions I did before, I ran up and down just to annoy people. So let's talk about the teams. Red team, blue team. What does that even mean? They have these random names, red team, blue team. So let's talk about the red team. These guys are the attackers. Oh, that's a long jump. These are the attackers. These are the hackers. So if we talk about Microsoft for a second, Microsoft have a red team and a blue team that focus on Windows Azure. And there's actually a video on TechNet you can go and watch, actually on MSDN, that talks about what they do to protect Azure. The red team are the hackers. They may not actually be hackers, but these are the security guys that are going to try and break into the stuff. These are the ones that didn't build the environment. You should never have the same guys test the security of your environment if they're the ones that built it. Doesn't really make any sense, does it? Like, why would you do that? Well, I built the SharePoint environment and tested it, and it's secure. And they're like, okay, check. You have somebody else do it. That's the whole point of the red team. Like, do you really want to have your name as, yeah, I installed it and it was great? So what do? What are the skill sets of these guys? And actually at the top, I put whiteboard. And you might think, why would the hackers need a whiteboard skill? Because that's the first task that you should do. And we'll talk about the whiteboard in a minute. But these guys know networks inside and out. They know how routers and switches go together. They know how to poison a router, which I've done before as a test. It's always good fun. If you set up a fake Facebook login page that looks like the original, poison the network router at the company where you work, and then steal everybody's passwords and usernames. That's always good fun. But that's actually really straightforward to do. It takes about 10 minutes, and you'll be able to get everyone's password and email address. But they know servers. They know Windows servers. They know Linux servers. They know all the different kinds of servers that you could think of. They also know applications and web traffic. They know how this stuff goes together. So the people that are testing know this stuff inside out. What do you guys know? Well, I know how to install SharePoint, and I can put SQL in, and I may know a bit of AD. I've built an infrastructure. Do you really know everything about the network? Do you know all the pieces that connect it all together? Well, probably not, because there's probably a network guy that does that. So what about the blue team? The blue team are the defenders. These are the ones that may know how it was built. They may have been part of that. These are the guys that have the same skill sets. How bizarre. The hackers and the defenders need to have the same skill set. If you're the guy that built the SharePoint environment, you can't really be the defender if you don't have this skill set. Because how are you going to protect from a network attack? And I'll show you some stuff in a bit. How are you going to protect yourself from that if you have no idea what they're doing? So be aware that the two teams are really the same, except they've allocated different roles. So why would you use a blue team and a red team? Why would you even remotely want to do that? Anybody think their SharePoint environment's nice and secure? What, no hands? Not even anyone. Anybody had their SharePoint environment on the internet as public facing? Oh, a couple. Is it pen tested? Oh, that's the next question. Pen tested too? Did it pass? Good. And are you sure? No, I'm sure it got passed, but whether are you sure it's secure? But yes, but that's the next thing. If you have an external facing SharePoint site, or let's just ignore SharePoint for a second, anything that's external should be tested by someone, whether it's an internal network team that were not part of the build, or whether it's another organization that you bring in. So let's talk about this whiteboard idea. I think too often what we do, we build an environment, and then we go out and say, test it, go, go, go. And they test it, and they come back and go, we found all this stuff. And you're like, that's cool. And then all of a sudden, somebody in the organization, you realize, has been downloading files out the SharePoint environment. You're like, how the hell are they doing that? Oh, we didn't test it from the inside. We just wanted to make sure that the hackers couldn't come in from the outside. You really think the hackers are sitting there going, you know those guys, they got some SharePoint stuff. We're going to take their stuff. You really think the hackers are really excited about that? No. Are you a bank? Then they'd be excited. Are you an online store? Are you a shop where you're taking credit card payments? Of course they're going to be excited. But your external extranet that you built for your vendors, I don't think they're really going to care. But you never know. So let's talk about the whiteboard then. The first thing we have to do is diagram the solution out. What is it you built? So the first question I want to ask you is, what are you going to draw on the board? So the challenge is, we're going to test our SharePoint environment. So what is it you're going to build? What is it you're going to write on that board?
Environment.
What environment?
Networking.
Okay.
Connect, servers.
So more than the SharePoint servers?
Oh, yeah, absolutely.
Okay. I've been to too many organizations where we do this exercise, and what do they draw on the board? Well, I've got a SharePoint web server, an app server, and a SQL server. And then my next question is, do you have an Active Directory? Yeah. So why is that not on the board? Do you have an email server? Yeah. Do you have a network firewall? Well, yeah. Well, let's draw them on the board too, because you need to know everything about the infrastructure in order to determine where those entry points would be. You need to understand the traffic flows. Where are your end users coming from? It's an exercise that's fantastic to go through. So I build an external-facing extranet. Who are these people that are coming to the site? Well, they're our vendors. Are you sure? Well, that's what they said they were. So back in the States, you may have seen it on the news, Target, the big company in Target, they had that massive, just a small few $1 million hack that took place. And do you know how they got in? Through credentials from a third-party vendor. They didn't break the door down and say, hey, Mr. Target, let me in. They stole credentials, compromised credentials from a third party, and then used that as a backdoor into the system. We're going to understand authentication flows in that diagram. How are we authenticating? Okay, I have two sets of users. I have internal users. I'm going to come in via Active Directory. That means I boot my laptop. I open HTTP SharePoint. My browser is going to post the cached credentials directly to SharePoint, and I'm in. How do my external users come in? They go somewhere and we authenticate them. And what about the other? How does that work? You need to understand the authentication flows and the traffic flows as well as the infrastructure. Then, only then, can you understand the weaknesses and vulnerabilities in that infrastructure. If you don't diagram it out, how do you know that there's some random Linux server sitting at the side of the infrastructure that lets anybody in? How do you know that the system admins have not enabled remote desktop to those servers so they can get to it from home because it's too much of a hassle to VPN in? And there's a few smiles, because I actually know quite a few clients of my own that do that. They're like, well, I don't want a VPN, so I just enabled remote desktop, port 3389, but I mapped it to a different one, but it's still on the internet. And then you can plan your attack and defense. Because remember, you're red team, blue team. Red team's going to do the attack, blue team's going to do the defense. So how are we going to do that? So this is the first process of this. Draw it out, diagram it out, Visio it out, whatever you want to do. I don't care. Draw it on a piece of glass. Whatever you want to do, and then work this process out. Once you have that in place, then you're able to move to start attacking and defending. So let's talk about threat analysis. You may have seen something like this before. 3 little things: threat, assets, and vulnerability. The middle bit is the risk. I don't want to bore you with all the theory of this, but this is what we're focusing on. The threat, our assets, and really what the vulnerability would be, and then really the risk to you as an organization. I often ask people the question and say, what is your content worth? What's it worth to your organization? If I came into your office with a USB stick, went to your SharePoint servers and sucked all the databases off and then went home, What's that worth to you? Well, apart from you lot getting fired for letting me do that in the first place, but what's it worth? What's in there that would cause you a problem? Are you storing personally identifiable information in there? And everyone's like, I would never do that. So what's the first thing we do? We do a search in SharePoint for payroll, salary, disciplinary, and then a whole bunch of swear words just for fun, just to see what people are writing in SharePoint. But how much is your content worth is really the risk that we're trying to mitigate by doing a penetration test. How much is it worth to you if someone broke in from the outside, compromised SharePoint, and then hopped around your Active Directory and deleted all the accounts? That's what it comes down to. So what are the attack vectors? So what is an attack vector first? It's a route or a mechanism used to get into a computer system. And there's tons of them. It could be remote desktop. It could be an SSH. It could be Telnet. It could be somebody walking. You know, you watch those movies, you watch the films, and they go in and someone breaks into an office and sneaks into a server room and puts a USB key in, and amazingly it does wonderful things that in reality don't actually happen. But they are attack vectors. How big do you think SharePoint's attack vector is? Is it small? Large. You know, back in the day, when I worked on SharePoint before it became SharePoint, so this would have been like pre-2001, the attack vector was probably like that, because nobody had it. And it was teeny-weeny, and all it could do was put documents in and get documents out. It did exactly what it said on the tin, nothing else. And if you think of SharePoint 2013, where do you begin? The last time I did some audits on some environments, people were using the great, they were using the auto SP installer stuff, and they were just pushing SharePoint on. And how many of you enable all the services by default? You don't have to raise your hand, it's fine. It was a rhetorical question. Kind of know the answer to that one. Yep, how many of you go in and say, start services? I'm sure most of you do. Well, I've got to have a resilient environment. I want every server to have every service running, so I can swap the servers backwards and forwards. Okay, so your attack vector that was this is now this, because I can go to any of the servers and access web service endpoints. I can access any of the stuff on those servers. So, but let's talk about the vectors for a SharePoint environment. And notice where we start. We don't start with the SharePoint server. We're going to start at the top of the tree. What's the most prize in your organization? Active Directory. If we can compromise Active Directory, just turn the servers off. Because I can create my own accounts. I can delete accounts. I could cause you more issue and pain than you can imagine if I can stay on your Active Directory server. But then we go down. What about backup systems? You've got a backup server that's running backup exec with agents on, or something else. That's another box that, oh, right there, it touches the SharePoint environment. If I can compromise a client workstation by utilizing something like a phishing attack or social engineering attack, I can get to whatever that user can get to. And then if I really wanted to, I can start focusing on the database server. And notice I put the database server above the SharePoint servers, because SharePoint servers are generally secure. Generally. It's us that make them insecure. If you install an out-of-the-box SharePoint environment that just sits inside your network and talks to Active Directory, it will be secure. You stick it on the internet, it becomes insecure. You decide you want to mess around with it a little bit and let's do some weird config. Start breaking it. You want to upload some weird JavaScript file. Not that I'm against JavaScript files or jQuery. I've seen too many environments where there's just weird stuff that happens when it goes in. But then the SharePoint servers are there at the bottom because it's actually very hard to break a SharePoint server. You could do a cross-site scripting attack. SharePoint 2010 was vulnerable to that. You could go to the calendar.aspx page and you could append a cross-site scripting attack. There was a great one that we used to do for fun. It's like about 5,000 lines of JavaScript, and when someone hit it, everything would float around the screen. And that was great. That wasn't an attack. That was just annoying. But you would send them an email, a social or a phishing email that had them go to the site that then did all that weird stuff. And it's actually not that hard to do. Let's run through a scenario and see if you would fall for it. So I call you up, and I call you and say, hey, it's Dave from IT Services. And you're like, oh, hey, Dave. You know, because that's what you would say. And you're like, there's been a problem with your account. Really? Said, so someone's compromised the system and they used your account. Like, have you used your account somewhere else? Have you been on holiday somewhere? Have you logged into work somewhere? You're like, no, I'd never do that. I am like the best ever. And he's like, okay, well, we need to reset your password. And he said, and there's been a bunch of other compromises too. He said, so we're trying to get a list of all the passwords that have been used, and we're going to block them as a policy. Now, I'd hopefully think you were smart enough to just go, yeah, whatever. But if I'm Sue in accounting, who doesn't really care, he'd be like, yeah, can I have your password? Okay. And you get your password. And then I write the password down and go, we'll reset your password. Just log out your computer. We'll reset your password. It'll be password 123, and you can reset it when you log in. Okay. And do I reset the password? No. And does she sit there staring at the screen for 20 minutes? Yeah. I mean, how great is that? But would you fall for that? Well, no, I would never do that. And you know what? People never fall for that. But someone did it at our work. They called up, and we actually had a message from the CTO telling us that phishing attacks and phone calls and social engineering attacks had been successful in our organization. Now, bear in mind, it wasn't hackers. It was actually our security team that were doing tests just to see how weird some of our users are. If you ever get bored one day, just do that. Just call random people up in your office and say, oh, I'm from IT. We've got to reset your password. You'll have loads of fun. So the attack vectors we talk about are really not SharePoint. And I want you to kind of leave this session knowing that SharePoint's one piece of a larger puzzle. SharePoint's not the problem. So what attack techniques do we have? We have what's called an APT, Advanced Persistent Threat. These are the ones where you've all heard of those zombie computers and everything else, where they just... That's an advanced one. It just keeps going and going and going and going. Then we have a denial of service attack. If you get bored one day, download a tool called Low Orbit Cannon, and then just point it at your corporate website for fun and just tell it to do 1 million hits, and it will kill the website in about 5 minutes. Not that I told you to do that. We can take that off the video. No. But you can do that. And that's a free tool that if you want to download that, find the anonymous website, and you can download it for nothing. It's there. They have that as part of their arsenal of tools. Then we have cross-platform malwares. These are a bit nasty because they hop between phones, they hop between Linux boxes, Windows servers, all kinds of different things. But that means I've got to put something on the machine first. So what do? I walk into your office, I put some stuff on a USB stick and just drop it on the floor and put a label on it saying files. Now I know at least one of you is going to pick it up and go, I wonder what's on there. Ting! And the malware's on the machine. And everyone laughs and goes, yeah, that'll never happen. But trust me, it does. Because you see a USB stick and go, I'll have that. Because everyone likes USB sticks. Then we have what's called polymorphic, I can never say the middle one, metamorphic malware. These are the ones that are slowly becoming organic. That means the first one kind of stays the same. It's very consistent code. The next one starts to kind of change with encryption. And the metamorphic one now grows and changes as it goes to different machines. We're getting very clever now. The malware that gets distributed and can be put on machines changes its footprint and signature as it hops through the network. Some of the coolest stuff that's there now is what it will do is it will be installed onto a machine, it picks up the antivirus, copies the digital signature of the antivirus, wraps it into the malware, and then distributes itself. So when it gets to the other side, the antivirus says, oh, hey, and carries on. Because it presents itself as the same thing. These are pretty dangerous, but they're still hard. You probably won't see some of these. And then we have phishing attacks. These are probably the most successful way of getting into an environment. A social engineering attack, a phishing attack of some description. So, the attacker from within. Well, let's ask the question first. We'll do a show of hands. Who's more nervous of disgruntled employees or hackers? No one cares. Doesn't matter, does it? Who's the worst, the hackers or the disgruntled employee? Are the hackers more dangerous? Maybe. Are the disgruntled employees going to cause more nightmares for you? Well, quite clearly. Because the attackers within, they're inside the network already. Like, I don't have to break down a firewall. I don't have to do some random port movements around to get in there. I'm already in. All I have to do now is figure out how to elevate account privileges to be able to do stuff. And this is the issue. We inherently trust employees. You know what? You shouldn't trust employees. Can you imagine if I'm your employee? You wouldn't want to trust me, but I have a smiley face and I'm happy. So of course you trust me, like, oh, he's so nice. As I'm deleting, no. But employees are always trusted because that's the whole point. You join the organization, you become a trusted employee. Should we name 2 employees that you probably wouldn't want to trust, or they wish they'd been trusted differently? Well, let's talk about Bradley Manning, who's now called somebody else. And then there's Edward Snowden. He was a trusted employee. That worked out well. And do you know how they fixed the Edward Snowden, Bradley Manning thing? Whenever they want to access files now, there has to be 2 of them together. Because obviously, only one of you would be bad at any one point. So they have 2, because I'll go, no, you shouldn't do that. Okay. Because that's how that works. Yes. You think that through. That's great wisdom right there. I should tell my kids that. Have somebody with you all the time, because one of you will always be right. They have access to more systems than me from the outside. Me as an external user. Those guys that did a penetration test, they only had access to what you gave them. It's like, see that box over there? That's all you can touch. And so they did that. That's all they touched. They didn't come in and go, let's play with the SQL box over there, because they didn't get in, because that was the whole point. But these guys are already there. The attacker from the outside, you may not know who this is. You may think it's the penetration testing team that you just asked to do something, but it's probably 16-year-old Steve who's at home with a bunch of Python scripts who's like, yeah, I'm bored. And just goes online and downloads a script, because obviously there's not real hackers anymore. They're all script kiddies, because they just go and reuse a script that somebody else has written, kind of like a lot of SharePoint devs. Oh, I shouldn't have said that. Shouldn't have said that one. That wasn't for you. But you know what I mean? It's like I can go online, download a Python script that'll brute force a remote desktop connection, and you will never know. I can download one of the largest password files on the internet, which originally came from the LinkedIn hack that took place, or I could go and get the one from Sony, or I get all of them. And then I just sit there and go, brute force. And the only reason you would ever know is if your Active Directory policy blocked your account out after so many bad attempts. But you know what? That's frustrating though, isn't it? As an employee, to know that if you get your password wrong 3 times, it locks you out. So what do companies do? They don't put that policy in place, because the IT admins are like, man, our users are stupid. We're not going to put that policy in place. Which means that me, as the hacker, just sits there banging at the door again and again and again until I get it right. And it's actually not as hard as you think. These guys can only access specific paths. You've told them the path, or if they don't know, they can only see what they can see. That's all they can see. Different ports, different protocols. That's it, nothing. They can't see the inside. They don't know what door they're banging on half the time. They focus on very specific types of attacks. They're not the same as the disgruntled employee who really just hops around. Now, I can do a quick test and see if you're like would-be hackers. Anybody ever gone into the file share and seen a folder and looked at it and double-clicked and it says access denied? You ever done that? Why? It's not your folder. Is it? Is it yours? You knew it wasn't yours when you double-clicked it. And you're like, that's not mine. Double-click. Oh, I wonder what's in there. You know this. I've done it 1,000 times. But you do it anyway because human nature, we are curious. And then we look at it and go, I wonder what's in there. You're like, oh, how can I get in that? You're like, who's that folder? And you ask other people to see, have you seen that folder? That one. Because you want to know what's in there. That's the way hackers think. Hackers look at things and try to think differently. Well, if I can't get to it that way, could I go this other way and get into the same system? That's the whole reason, the motivation for it. It's curiosity that makes people do this. It's the challenge. They have a limited surface area of attack. Not like the inside. I can see everything. On the outside, I can see the website. And based on most SharePoint implementations, I wouldn't want to break into them from the outside anyway, because there's nothing useful there. Which was really strange when Bradley Manning took all the documents out of the SharePoint environment that he had access to. The news article came up and said he took 250,000 documents. I was so amazed that somebody put 250,000 documents in SharePoint first, and then secondly, that he got them out. Have you ever tried getting multiple documents out of SharePoint? 1, 2, That's a lot of documents and a lot of time. No, he used a one-line script. It was a wget command, and it took 20 minutes. It's actually really straightforward to recreate. I actually did that in a session in California a few years ago. One line, all the documents came out. So it's actually not that complicated. He wasn't a hacker. He was a disgruntled employee who just figured out you could use a wget script. And do you know what they did? They made the site SSL. That's secure. But you know what? The wget script allows you to just go, don't check the certificate. And then it ignores it, and it worked anyway. So there are things that we do to make things secure that really are not secure. So what are we going to look at for an attack? So in the environment that I'm playing with, I have a switch. I have a whole bunch of servers. I have a bunch of firewalls and a bunch of ADFS stuff because I'm using it for other stuff too. And they're all connected. And then I have this little machine over here. And this little box is my machine that's over there. And it's connected to the outside and the inside so we can play. And actually, the attack we're going to go for is we'll look at the Active Directory first. Let's attack the Active Directory. So I'm going to pretend to be a disgruntled employee on the inside. And what I managed to do was download some tools that I could use. You can use them on Windows, but I'm going to use them on Linux because I like to not use Windows in demonstrations. It's just way cooler to look at command console things. It looks way more sophisticated. And then we'll get bored and we'll attack SQL. And that's the attack that we're going to go with, because you want to think, disgruntled employee, let's say it's an IT person, kind of knows a little bit about the infrastructure. Wouldn't it be cool if you could break the Active Directory and create an account, and then elevate it to where you want it to go? Wouldn't it be cool to break the SQL Server and go into the SQL Server and elevate yourself, and then just for fun, we'll stick a keylogger on the server and see what people are typing? Now I'm going to show you how to do this, but if you ever use it, I will know. So let's have a look at attacking. Wrong way. Okay, so first off, let me just go to the first box that I've got here. It's running, so I have a bunch of servers, but we're going to use this one for now. So this one is my Active Directory. Looks very sophisticated. You can see I've got a whole bunch of accounts. I've got user accounts. I've got SharePoint accounts. Basically, this is the brains of my organization. This box also, the SQL Server I'm connecting to. Really? Yes, that was a longer password than normal. It's actually 20 characters. My standard passwords are 20 characters now because I don't trust anyone. Not even myself. So we have our SQL Server. The SQL Server over here, if I can get my mouse to go up there. If I expand it, there you go. That's an important SQL Server. That's my SharePoint 2013 environment. It's running SQL 2014, which is nice and secure. New version. I thought we'd try the new version out. And then we have a whole bunch of SQL databases. And if you notice, it's running workflow services too. So there's about 500,000 databases in there, because when we do an install, that's what we get. At least they've not got GUIDs. Anybody SharePoint install got GUIDs in it? If you do, I was going to ask you to smack yourself, because that's not a good thing. So the first thing we want to do is we want to utilize a tool called Nmap. Nmap's been around for a long time. And what I want to do is I actually want to scan the network. I want to say, hey, go ahead and find me some boxes. I want to know what's there. Anybody can do this. You don't have to be an admin. You can just go in and do a scan. And to make my life easier, I've put stuff over here so I can copy and paste. And then I'll make some of this lot available. So I'm going to go in and do an Nmap scan. And there we go. So this is going to go ahead. So it's scanned my little ring fence of servers. The rest of the servers sit outside that. For ease and convenience and performance, I've chose a couple. So we have a server on 40.133 and a server on 40.135. And the key here is the server on 133 is the box that I'm on. So I don't want to attack that one. Plus it's a Linux box, so there's no point. So what do I want to do? Well, the first thing I want to do is, when you do a penetration test or a security test, what you're actually going to do is you're going to first do some reconnaissance. That's the first thing. So I did that. That was a very quick, done. The next step is fingerprinting. Not real fingerprinting. That would be cool. We'll all get out and put our, yeah, I'll take your fingerprints on the way out. I'll need those. But we fingerprint the devices that we want to use. So we're going to run a different command. We can still use Nmap. And nmat will allow us, where'd that go? There we go. Nmat will allow us to do a fingerprint to a specific machine. So I'm going to take this command, and I'm going to paste it directly into a different tab that I didn't want to. But let's do paste, and we'll fingerprint the server. Now this will take a little bit longer, because what this will do, imagine what it's going to do. It's going to walk up to the server. It's going to bang on the door and say, right, me and you are going to have a chat, and you're going to tell me everything. And the server's like, yeah, it's not going to happen. And he's like, no, I'm going to force you into it. And he's going to tell you the ports that are open. It's going to have a good guess at what the operating system might be. It's going to have a good go at really trying to understand what that device might be. Now, we may have to leave that going because it's going to be a lengthy process. And the server tries to deny it and says, like, no, 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 no. But eventually it submits and gives in. And you can do this to any device on the internet. You can point it at the IP address and have it go and scan. When it comes back, it'll be pages of stuff, and we'll go through that in a second. But what this box is this box is my connection to information in the network. So we'll just refer to this as the Active Directory. Now, while that's running, we'll leave that going. And what I'm going to do is just flick to a different console window that's here. And we're going to introduce a tool called Metasploit. Metasploit can go on Windows, but this is running it on Linux. Metasploit is like the big daddy of tools to use. This is a framework. So what I'm able to do is use this on the devices, or what we're going to refer to as the targets now, that we want to use. So I'm going to go ahead and I'm going to use the IP address of the box that we've just got. I've already ran MSF console to run it. And then I'm going to go over here and I'm going to type something that says use exploit Windows SMB PSExec. Now what this is going to do, this is going to go into a folder and find an exploit, which is going to launch basically a remote executable kind of connection. And we're going to pass it a bunch of parameters, and this is specifically around Windows, because that's what we're targeting. So I'm going to go ahead and connect to that. Once we have that connection in place, what I'm then going to do is pass it a whole bunch of parameters. So for ease and convenience, before I paste all of that, what I'm going to do is go back to our Active Directory, and inside user accounts, you'll see that I have some standard accounts. A John Smith, a Gloria, a Scott. These are regular user accounts in the Active Directory. I could have used administrator, but that would be cheating, because obviously I'm trying to be them. So I'm going to be John Smith. So I'm going to use John Smith's account with his super, super secure password of pass@word1. Because, of course, you all have secure passwords like that, I would assume. This is the one that Microsoft tended to use a lot on their VMs before they changed it. But what we've actually done is we've told it that our host is the target. This is the box we're trying to attack. And then what I've done is I've told it to use what's called a reverse TCP. What I basically want it to do is give me a command prompt on the Linux machine. It's actually pretty cool. Can you imagine that? I want a Windows command prompt on a remote box, which is not running Windows. So I tell it to do that. I then tell it that my box, which is actually the 133 box, is going to listen on port 44444. I think that was too many fours, but yeah. It's going to listen to that, and I'm going to pass in a username and password. So jsmith and pass@word1. So I'm going to try and now connect to that environment. And of course, what's great when you want to run something, you feel like a proper hacker because you have to use the word exploit. So I go ahead and do an exploit, and it went straight away. And it hopped across. You'll notice there's a weird executable that just appeared somewhere. That's what's called the payload. So I now just connected to the Active Directory server as John and uploaded some malware. That's really what it was. I uploaded a piece of malware that got dynamically generated, and it dropped it in there, and then look, I have a command prompt. And to just prove that it's not smoke and mirrors, let me just type hostname, and that should be like spdev or something. So I'm actually on the server as a remote command prompt. So that's my Active Directory server in Linux. How cool is that? So what are we going to do now? What would you want to do? Oh, delete all the accounts. I was a regular user. Correct. The regular user doesn't have a permission to that one, but what the regular users are able to do is to make a connection to LDAP, to put files into shares on an Active Directory server as a regular user. I know, but you can't go and delete stuff in Active Directory and do things like that, which is what I want to do. No, I'm not going to delete anything. But what we're going to do is this account, John Smith, is one of those power user people. He's not an admin. He's not an administrator, not a domain admin, just a regular user who can do some bits and pieces. So what I'm going to have him do is just some very old school net user commands. So let's go into here, and I'll do net user and add an account. And then I'll go and say, let's add that account to the local administrators group. Now, bear in mind, a lot of the legwork is being done by the framework, because the framework has pushed a piece of malware that looks for vulnerabilities in the platform, like Active Directory or Windows, and then elevates things so I can do stuff. So, what did it do? Well, let's have a look. Users. There we go. There's my hacker account. And I created an account, and it just added me to the local administrators group. Nothing else. So I'm just a domain user with administrator rights on the box. So that's cool. I still can't do domain stuff because I'm not that cool yet. Even though you're a local administrator doesn't mean you can modify the Active Directory. So I have a little bit more privileges. This is what's nice about the Metasploit framework, is it lets me hop up and do things. So what we want to do now with that account is we would like to go through and make that account something a little bit better. Or let's just change it. So what we're able to do is do what's called changing the payload. So remember the payload was that little executable that suddenly appeared over there? The only way you would have stopped that executable is if you had antivirus that would have picked it up. That's how that works. And the payload that gets generated is a whole bunch of code that you don't want to look at, but it generates bits and pieces that we need.
Would it have stopped it from running straight away?
If the antivirus would have caught it, it would have seen it as something and would have blocked it at that point. Or you can actually put policies on the server that, so like for example, the Office 365 infrastructure, the servers themselves are actually restricted from running any executable that's not on the whitelist. So you can actually create whitelists for the servers and say only allow Explorer and whatever else to run and blacklist everything else. So you would get around that by creating that. So I'm going to change, oops, I need to come out of that one, sorry. That doesn't work in that window. So let me go back to here and change. Yeah, those commands don't work in the actual window there. So I've changed it to what's called a reverse HTTPS connection. I don't need a session now. I don't need a command prompt anymore. So what I'm going to do is I basically want it to return what's called a reverse HTTPS shell from that box. So I can go in and say exploit, and this will go ahead and exploit. And what you'll see is it went ahead and did the same thing again, but a different payload. The payload went on the box, it requested it, came back, and now I have this weird-looking shell, which is not Windows. This is specifically the Meterpreter shell available to us now. So what I can now do is I can do load incognito. And this is a great extension. Load incognito, kind of like the browser, kind of incognito type thing, allows me to almost become somebody that I'm not. So list tokens -u. So what this will do is this is now connecting directly to the Active Directory. It'll list in a second when it decides to wake up. It'll list tokens or user accounts that are available for me to do stuff. Now think about this. This is my Active Directory server, and of course it's going to have lots of things. It could be the SharePoint server. It could be a whole bunch of things. So it has what's called delegated tokens. This means I can take that token and I can become that person. Now, which person shall we become? I'm thinking the top one. I would like to become the administrator for at least a few seconds. So I'm going to go in and say impersonate token, because that's how that works. And let me just go down to here. And I'm going to now impersonate that account. Now, what this will do, this will talk to Active Directory. It will go through and it will say, can I impersonate that user? And it will either come back as an access denied or it will work. Hopefully it will work and will become that account for a short space of time. You won't get that forever. Really? I got a timeout? Hold on for 2 seconds. Let's see if it comes back. This may be a separate issue. If not, we'll do it in SQL. But we can impersonate the account as that one, which seems to time out for some reason. I must have lost network connection. But I can become that user, then I can take my account that we created, that underscore hacker account, and I can then create it as a domain admin. Because at that point, I become the domain administrator. Now just think that through for a second. How long did that take? 5 minutes? Now, of course, not everybody's able to do that. And your account may not have. You may be like a lockdown restricted user, so you would never get to do that. Or you may be, if you're a system admin, of course you don't need to do this, do you? Unless you're trying to cover your tracks. How many of you are IT admin, kind of sysadmin type people? How many of you use your regular account to log into everything? So your regular network logon account to administer the servers. That's good. I have to check. Still people that do that, believe it or not. So you all have 2 accounts at least. A regular one and then an admin account to do stuff. Or do you have like a dedicated support one that you all use? Because I've seen that before too. Yes, we have right there, it's like SharePoint. How many people know the farm service account? Tends to be quite a lot of people seem to know the farm service account. So I don't know why it's not connecting, but it's obviously timing out with network. So we'll show you the last command. The last command that would have run would have been this command here, which would have then allowed us to execute a command prompt under the context of that user account. So I would have then been administrator, and then I could have done whatever I wanted to at that point. So that's kind of one attack that we can go with. Now, if we flick back to here, you'll notice that my Nmap scan just came back. Notice how much information it brought back? So it had a long conversation, and it won. It comes back with server builds, ports that are open. It comes back with information about traffic. It then tries to guess what the operating system would be, and then works its way through looking for information and brings it all the way back. You know, some of that information is also exposed inside SharePoint too. You can get to that in some areas of SharePoint. So our servers are exposing lots and lots of information that we may not want anyone to know, but me running something like this will allow me to do that. Now let me just flick screens over here. And what we'll do is do something a little bit similar. And what I'm going to do is I would like to, let's go and play with the SQL Server. Because everybody thinks SQL servers are always nice and secure. So I'm actually going to run something called MS SQL ping. Because I really want to know if there's a SQL Server somewhere in the environment. I actually happen to know there is, funny enough. But you can actually run the scan, and it will go up and down the tree and look for information. So what I'm going to do is whenever you run a command in here, you can do what's called show options. Show options allows me to pass parameters. I can pass a password, the target, a username, password. Anybody know if their SA account is enabled in SQL? Anybody installed Access Services in 2013 properly? And then had to enable SQL authentication along with Windows? Or are you such great admins that your SQL servers are only only Windows authentication? Or are you not sure? There seems to be a lot of blank looks. Like, what did he say? Only Windows is the way forward. But if you want to run everything correctly, you'll actually have to enable both to get certain things to run if you want to do that. Or you may have other applications. The first no-no rule, your SharePoint SQL environment shouldn't be running anything else. But sometimes that happens. We go to the SQL environment, you're like, why is SAP over here? And then they wonder why stuff is slow. But that means that configuration is done incorrectly. So what we can do is go in, and I can set the R host to that box that I wanted to get access to. And then I'm able, oops, I didn't actually get what I needed. Here we go. I'm going to just exploit and come back. So it goes to the box straight away, and SQL Server says, I'm here, and tells me the version. And it really does. You just ask it and say, are you SQL Server? Yes, I am. Because SQL's a big boy. It's like, yes, I am. I am the daddy. I've been around for a long time. So we look at it and go, well, that's interesting. What about if we try to get into you? So we're going to run something called SQL login. And then what I'm going to do is, because I really want to be nice and secure, I'm actually going to tell you what, let me just minimize to the desktop. And what I'm going to do is use a password file. And it's only going to have a few passwords in it. But those are the most secure passwords you've ever seen. Are they not? Surely? You know, these are some of the top 25 passwords for 2014. Yes, they are. Because everyone knows how to make secure passwords. As IT admins, you'd be like, they're not secure. But everybody else would be like, yeah, they're not too bad. I might use that one. But you know, those are on the list of top 25 passwords for last year. So what we're going to do is I'm going to just say, hey, set the password property to just be nothing, and then pass in a file because I want you to try ahead and break into that. So I'm just going to pass it in, pass the password file, and then I'll exploit that. Oops, I didn't actually set the R host. 40.135, and then we'll exploit that. And there we go. So it now hits the SQL Server box and says, let's go, let's go. Fail, 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 fail. Ta-da! Trust number 1, the most secure password ever. Now, if I'd had a password with 20 characters and I had a dictionary file, obviously you would like to think that you as the IT admins would be monitoring the SQL Server, so you would see this. But that's not going to happen because no one likes to look at log files. So this is going to go ahead, and it's never going to lock the SA account out. Why would it do that? But then again, if you're in Windows, you wouldn't need to, because it would just go, nope, can't connect. But I was successful. I successfully connected to my SQL Server because of a bad password, and the SA account was enabled in my environment. So what I'm going to do now, just to make it even more complicated, is I'm now going to enumerate that SQL Server, because I now know the password for everything. So I'm going to tell it that I need to use, oops, I think I typed too many different things. Let me try that one again. And paste. We'll leave that going. That'll catch up eventually. So this is now going to launch me what's called SQL enum, and then it's going to say, that's the wrong IP address. It's now going to say, that's my target, and then the password that we know of, I'm just going to reset the R host, because that wasn't the right IP address. 5. And then I can exploit that. Okay, and it came back and said that's successful because it didn't take the code that I wanted it to take. 2 seconds. I just need this one on its own. And we'll paste that. It's like my machine's playing catch up. Really? Don't you love it when demos just don't work? Auxiliary, admin, MSSQL, oh, there we go. Maybe I typed it wrong. Ah, dear. It's because you're watching me, that's what it is. I can't type when people are watching. 35. Let's do this. And let's do this. And let's do that. There we go. That was what I wanted. So we just hit the SQL Server very quickly as that account and then said, give me everything. What have you got? So it goes and gives me stored procedures. It goes and gives me file locations of all the databases. So if we go back, all the accounts, you'll see all the physical locations to the files. So I know where everything is on that server now. Now, I'm not physically on the box. I'm still on my Linux server. Now, I still can't remote desktop to it because I don't know how to get to that box. I know the IP address, but I only have a SQL account that's not going to let me do anything. But what I want to be able to do is start messing around and making some changes. So I'm going to tell it to use what's called an executable mechanism for SQL. And it's because I've typed auxiliary wrong, that's why. No, I think I still spelled it wrong. Use auxiliary, admin, MSSQL, exec. There you go. And what we'll do is we'll just scroll down so I can use the last little pieces, and And then what we're going to do is this one allows me, you can see from here what we're doing. We're connecting to the host. I'm passing the password, and then I'm telling it a command that I would like it to do. Okay. Now, anybody who knows what netsh commands are will notice, well, let's have a look first. XP command shell was a vulnerability that was there years ago. It's a stored procedure that gets disabled by default for this very reason, because I can run command prompts from SQL Server. But actually, the framework enables that for me, which you think, well, that shouldn't do that, but it does. It enables it because I'm the SA account, so I can enable that. And then it goes in and tells me, hey, what's the firewall status on that server? I'm talking Windows Server Firewall. So it tells me that the firewall is enabled. Operational mode equals enabled. But I'm really bored because I want to connect to the box properly. So I'm going to go ahead and I'm going to say, you know what, let's just set that to that and exploit. And, cool. And that's what you should get. You should be able to get, it should say run as administrator. My SA account, even though it got me certain bits and pieces, the box itself is now blocking me. You should get that. Should I be able to turn that off? Well, you would like to think not, but you can. The SA account needs to have different permissions, but the SA account on my box has been restricted down. Because when we talk about protection in a second, which we'll do now, I just realized we ran out of time. Oops, where'd it go? That when we talk about protecting the infrastructure on the database side, those are the things that we need to do. You need to do server isolation. What does that mean? Windows Firewall. Leave it on. Don't turn it off. I have clients that have turned it off on their boxes because it's easy for them to get to the boxes. But the actual server isolation is one rule in the firewalls that says block all traffic if it's not in the rules. Don't switch that firewall off. Create rules to allow traffic. In the old days, you would have done IPsec policies to say server A can talk to server B and vice versa. Do that. That's how you control access. You don't need me as an end user actually having direct access to the physical server because the firewall doesn't block me from getting to it. Put a policy in that says anything in this VLAN or subnet can talk to those servers. Anything outside of that, which should be me, can't connect to that. Use separate instances of SQL. Anybody using one SQL instance for SharePoint? Yeah. So if I break that instance, I get everything. Creating multiple instances allows us to protect the data better. You have an instance for config, an instance for the content, an instance for anything else that you're breaking out. Then you can run multiple instances on different ports. Who knows what the two ports are for SQL? And 1434. One's TCP, one's UDP. How great is that people knew that? So does everybody else on the internet. So if you're running 1433 and 1434, I can download something like SQL Recon, which is just an executable for Windows, and it will look around your network for anything that responds to 1433 or 1434, and it will go, that's a SQL box. Well, why would it not be? Change the ports, remap the ports to something else. Then your connection from SharePoint will still work because it still makes a connection across. But that means nothing will be able to propagate. Anybody remember years ago the whole I love you virus and everything else? All of that lot? That propagated through known ports from server to server. If you change the known ports and isolate them out to a ring fence with different ports, that would never have happened because it had no way of propagating because there was nothing for it to propagate to. The SQL browser service, first thing you should turn off. When you do a base install of SQL 2014, the browser service is not enabled by default. If you enable it, I can find SQL. If you're using monitoring software, you normally enable that because it needs to be able to find it. But that will mean you're now available to the world. I can see you from the network. And then we do a least privilege. Not everybody should be admins on the box. Not everyone should be domain administrators or anything like that. Application servers, same option. Server isolation and least privilege. No one should have admin accounts. Your account should not be an admin on those boxes. You should have dedicated accounts that can then be audited and traced. server isolation with the firewalls. If you're using web servers, exactly the same. Server isolation again, least privilege, and then an edge firewall to protect the traffic coming in and inspect the traffic. Content inspection is a big thing. We have a client where they're passing streams of XML from one place to another. The content inspection matches the packet that comes in, and if it doesn't match, it drops it. And they've stopped multiple hack attempts of people that have tried to construct XML packets that are not quite what's expected. It's a lot more complicated, but you'll be guaranteed to not have other people come into the system. Now, if we were going to build a secure SQL environment, we're going to start with the disk and SQL and SharePoint. We're going to bitlock the drives. Why would you not? You need to bitlock the drives. We're going to have a content instance that runs on a different port, and then we're going to have all the web applications are going to talk to that SQL instance only. So that's your content. Your content is now in a specific SQL instance. Then we're going to run the same thing again, and we're going to have a configuration instance where your config database will be, and then the service application databases will reside there. And then you're going to have your auxiliary services like workflow and a whole bunch of other stuff in this side. None of those should mix. Because if you're trying to be ultra secure, then break everything apart. The more you shove into one place, you've just increased the attack vector 50-fold. Protect the infrastructure. Anybody got something like this? Servers and then an edge firewall? That's normal. Anybody got something like that? Multiple firewalls? That works pretty well. What about something like this? Multiple firewalls, multiple subnets, and we isolate them all out by IP addresses and access control everything because we don't trust ourselves. And then, of course, we go crazy and we do this. And we're like, you know what? Screw it. Stick the SQL servers in India. And we'll put the SharePoint servers in London because the data connection is so fast. That's what we'll do. You can do this geographic dispersing. And it works pretty well. But you normally get this design when you're looking at disaster recovery, you're using always-on availability groups in SQL, and you split stuff between locations. But you can do it here too. Some various options of protecting the infrastructure that are available. So, inside SharePoint itself, don't ever change this one, the page parser paths, inside the web config for SharePoint, because then you can run stuff in the page that you shouldn't be allowed to run. We had a client that switched all this off, which is protection for things like running code in master pages, and then they wrote code that ran in master pages. We kind of defeated the purpose of the protection that's in there in the .NET. Call stack, false. Anybody have that as true in your environment? You're going to go and check now, aren't you? It should be set to false. Unless you're debugging something, it should be false. Allow page level trace, that should also be false, not true. Because things like this inject information into the page that you don't see. But I see it. When I do a scan of the page and say, go and get me the home page of a site and do a get command from a command line, I get the raw HTML, which injects a whole bunch of stuff about your environment in those pages. Make sure the safe control list is limited to what you actually need. Anybody seen that where you deploy a WSP and there's like 50 million safe controls and you can never get rid of them? Go through and clean them. Clean it properly. They shouldn't be there. Custom mode for errors, is it on? Or have you turned it off to off? Because you don't like the GUIDs that Microsoft give you. Unless you've replaced it with some other mechanism, it should be on because we don't want to send a would-be hacker a .NET stack trace. Because that's what you'll get. Because most of them are pretty clever about figuring out how that page works from a .NET stack trace. And then this is an interesting one that works pretty well. Protect your servers, making sure that all of the traffic in and out of your SharePoint environment goes through a reverse proxy of some description. Don't allow the servers to have direct internet access out. Because it means if I get on the box, then I can reverse and send stuff back out the other way. But if it goes through a proxy server, it'll get picked up and then it gets stopped. So finally, SharePoint attack area is massive. We just looked at Active Directory and SQL. We could have gone through the whole SharePoint thing, but you can't do that in the time. If SQL Server's compromised, you might as well just turn the rest of the servers off because I can just take the database backups. But then if you ran encryption, if you're running transparent data services on SQL and encrypted the content databases, I could then take the database and go home and then do nothing with it. unless you're like one of the companies that I worked with before where they were testing it and the private key was in the same place as the database backups. So that means I could have restored the whole thing anyway. But it was just a test, so we're okay. Don't just assume that everything out the box is secure, because it's not. How many of you have changed the passwords on your home wireless networks to be something more secure? Well, there's a few hands, and there's a few that are like, I don't know, I'll just connect to it. But you know what? I started off a session in Barcelona a year ago, and I started the session out with a webcam that somebody hadn't changed the password to, and it was a webcam of them sleeping in their bedroom. And for most of the session, I crossed my fingers, hoping the guy had clothes on when he stood up. But it was a webcam that somebody hadn't changed the password to, and it was broadcasting itself, and we found it on the internet, and I projected it up on the screen as an example of don't inherently trust. Just because you bought a third-party component for SharePoint doesn't mean it's actually secure. There was one component that's been out there for a while that actually, if you install it and use it, if you hit the right page, you could find a SIP address, an email address, and a domain login in the page in the background. You wouldn't see it from the SharePoint side, but if you looked hard enough and knew where to go, the page would appear and you could see there. And there were tons and tons of tools. Use the tools. Come to embrace the world of Linux. No, you don't have to. But there are tools on Windows too, or come to embrace those penetration testing teams and get to know them, because they will be able to tell you how to test it for yourself. So, last but not least, remember that often the entry point to SharePoint is not SharePoint, because there's nothing to really break into SharePoint with, that the breaking point is something else. It's the odd server that you built years ago that's under your desk that was just there for testing that now has become a gateway for all of the hackers. Or it's the Active Directory that me as a disgruntled admin is able to compromise, or the SQL server, or the Exchange server, or the backup server, or blah, 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 blah. That's how people get into systems. So when we build our SharePoint environments, remember those steps and make sure that we test it ourselves. Or make sure that we build it properly in the first place, because it's much easier to put the policies in place to begin with than to try and go back afterwards. I worked with a client where we had to do it after, and we had to have Wireshark in between every single layer of the servers to know what traffic was going where. Then we could create the rules in between, and then it worked. But make sure you do this first before people start using it. So, security is not an option anymore. You should all be freakishly paranoid about anything, and then go back and study on securing SharePoint. You know the documentation on the Microsoft TechNet site is actually pretty good. Publishing SharePoint correctly, locking down SQL servers and everything else, and hardening is all there. Make sure you read that documentation. So, thank you for attending, and I'll take questions while I'm packing up over here. Thank you for coming.